Good morning, students. Good morning, students.
Good morning, sir.
So we are going to look at how to convert x value to the z value. That is s value to z score or z value. Okay. So previously we discussed the importance of using the z value. So let's look at what we have today. So let s be a continuous random variable that is normally distributed mean and variance. Okay, so what we try to say here is that S is normally distributed with the mean and the variance. So you can either use the variance or use the mean. Okay, so this statement can be written in this form. Now, a particular value of S can be converted to its corresponding Z value by using the following formula. For instance, for you to have a Z score or Z value, you must know the value of X, you must know the value of the mean given, you must know the standard deviation given. Okay, so based on this, if our S is 3.2, then our given mean is say 3.1, and this is 1.3. So here your Z score will be 3.2 minus 3.1 all over 1.3. So what will be the Z score value? What will be the Z score values, class? 0.07. 0.07. Okay, so if we're interested in computing this probability, we use the standard normal probability distribution table. Okay, so let's take this illustration. So let S be a continuous random variable that has a normal distribution with mean. This is the mean. Population mean is given to be 50. Okay, and the standard deviation is 10. 10. Okay, so remember, this is the formula you want to use. All over this. Okay. So here, say convert the following S values to Z. So this is the first S value. So your first S is 55. So you have 55. S is Z1. 55 minus 50 all over 10. What is your Z value? 0.5. Okay. Then the second one, your X is 35. So Z2 equal to 35 minus 50 all over 10. This is your value. What is the S value, students? Minus 1.5. So this is how you can compute convert the X value into the Z value or Z score. Student Faham? Faham? Okay. So now see this example. Say let S be a continuous random variable that is normally distributed with a mean of 65. This is the population mean. Okay. Is the population mean 65. And a standard deviation 4 to 15. Okay. So it says find the probability that S can assume a value. So the first thing you have to do here your S is given to be 43. So you have to look for your Z value. So your Z value will be 43. That is 43 minus 65 all over 15. So what's your Z value, students? Minus 1.47. So say the less than. So you now say P Z is less than minus 1.47. So at this stage, what you do, you go to the standard normal probability table. Okay, you saw how we used it last time. Okay, so in doing that, you try as much as possible. You want to locate the probability value. So what we do, let's go back. Let's go to the table. Are you with me, student? Are you with me? Okay. So from here, this is your 1.4. Okay. So the next thing you have to do, you look, this is 7. Okay. So you can come down 7. So this is where it meets. So this is now your probability. 0.7078. So here, your probability will now be 0.07078. This is now your probability. Okay. Now the second one here is greater than 74. So your Z will now be 74 minus 65 all over what? 15. What is your Z value, students? 0.6. That is 0.6. So you will now say P of Z is greater than, okay, 0.6. 0.6. Okay. So to write this, you will now write that this implies that 1 minus E is less than Z 0.6. So see this greater than sign here because we always work on the probability less than. So we translate, we'll convert this greater than symbol, okay, into 1 minus this. So we translate it into less than. So on this basis, we go back to the table. So like what I said, we now say 1 minus P of Z is less than 0.6. Bring out your calculator. So here you're going to have 1 minus 0.6. This is 0.6. Okay. So this is the value. So you now have 1 minus 0.725775. What is the probability? 0.2725. 0.275. Okay. So let's go back. So you see how we got it. So remember, we can say 7258. Okay. So here we can now write this, okay, in this format, that 1 minus 0.7258. Okay, so we have 0. What? 27 forward 42. So anytime you have this greater than, okay, you simply convert it to P less than Z, okay, whatever value. Are we together on this? Are we together on this? Okay, so let's look at this. So let's say for Z1, okay, here our X is 56 minus 65 all over 15. So what is your Z1 value? Minus 0.6. Sure? Okay, so let's go for Z2. Here, X is 71 minus 65 all over what? 15. So what is your value? 0.4. So what you now write, you cannot say, you can just write this, for instance, that P of Z1 less than, and let's just put X here, for instance, Z2. Okay, so individually, we can now write the probability Z, Z1, Z2 less than 0.4 minus probability of Z1 less than minus 0.6. So we have equal to, so let's go to the table. So we have P Z1 less than minus 0.6. So what is the value? Let's go check minus 0.6. Minus 0.6 is 6. Okay, 2743. Let's say 0.2743. So let's check P of Z2 less than 0.4. So what we have here, 0.4 is 6554. 0.6554. Okay, so you can now write this, that P Z2, okay, less than 0.4 minus P Z1 less than minus 0.6 is equal to 0.6554 minus 0.2743. What is your answer? 0.3811. Well, okay. So now what we do, we go back. So here, the probability is 0.6554 minus 0.2743. So what is the answer? What is the answer, students? What is the answer? 0.3811. That's how you got this. Paham? Paham, students? Okay. So proceed. Okay. Okay, so that is the end of that. Okay, so proceed again. So far, so good. I guess you already know how we can compute the probability. So let's look at this sampling distribution. Okay, we have to look at population distribution. Okay, you know, I have told you guys in for previous discussion that when we talk about the population, we are talking about every individual that is located in the particular area of interest. Okay, for instance, we want to talk about the population of people in Sintok. It means that we are going to consider every individual or every element that resides within Sintok. Everything. Now, on the other hand, if we want to make a sample from Sintok, we only take few number of elements in Sintok to represent the entire population. So when we do that, we are talking about sample. So it is good for you to understand, distinguish between population and sample. Okay. So in previous discussion, we have extensively talked about probability distribution, how you distribute the probability based on the value of the random variable. So let's see what we have now. So let's look at this. Definition. The probability distribution of a data from the population. Okay, so let's see. Suppose there are only 5 students in an advanced statistics class, only 5. Okay, the midterm score of these students are given as this. So if you look at it, it is arranged from the lowest to the what? Highest. Okay. Now, we want to look at population distribution. So we say, let S represent the scores. So the mean of S, that is the mean of S, that is the population, written as mu X, okay, is given as this. You add up everything, then this is what you have done. 1, 2, 3, 4, 5. So it's like you write mean of X is equal to summation of xi, I from 1 to what? 5, all over what? N. So the N is 5. Okay, this is your x1, this is your x2, this is your x3, this is your x4, this is your x5. So you add up everything together. When you add up everything together, what is the total students? What is the total of this? What is the total? Give me the total. What is the total student? 403. 403. Divide by 5. What do you have? 403 divided by 5. What do you have? 80.6. So that is how you got this value. Okay. So you now look at the population standard deviation. Okay. First, you can look at the variance. Okay. So you use this formula. Here you say summation x square I from 1 to what? 5 minus summation x square all over n all over what? N again. So this will give you the variance. So to get the standard deviation, you take the square roots. Okay, so you take, to get the standard deviation, you take the square roots of, so that is how you got this. Okay, so by the time you square everything here, okay, students, let's do this together. Let's do this together. Okay, bring out your calculator. Bring out your calculator. Okay, so square this plus square of this plus square of this plus square of this plus square of this. What do you have? What is the total? 70 square plus 8, 78 square plus 80 square plus 80 square plus 95 square. What is the total? 3289. 32809. Okay, now the sum of this was 403. Okay, 403 square of 403 is what? What? 16 what? 164836. 164836. Divide by 5. All over 5. So here you have 32809 minus. Now this divided by 5 is what? 164836 divided by 5 is what? Hello students. 3248. 3248. 1.8. Okay, all over what? 5. So what is the difference? The numerator difference? 327. 327.2. Okay, so what is the variance divided by 5? What is the variance? 6544. 65.44. So this is now the variance, isn't it? Okay, so let's look at the standard deviation. What is the standard deviation, students? Are you sure? 80, 89. Good. So that is how you got this value. Okay. Paham? Okay. Okay, so let's progress. So now we now talk about the distribution, the probability distribution of X. Probability distribution of X, okay? So you see here we have 70, 75, 80, 80, 95. Okay, so we can form the probability distribution here. So we say X, we say frequency. Look at it. Have 70. How many times did 70 happen, occur here? How many 70 do you have? I have 1. 75. How many 75? 1. 80. How many 80? 2. Then 95. How many? 1. So the frequency is how many? Add it up. What do you have? 5. So now you can form the probability. Okay, let's see. How do you get this? Divide by everything here by 5. So 1 divided by 5 is what? What do you have? Decimal. What is the value? 0.2. Okay, this will give you 0.2 also. So 2 all over 5, what do you have? 0.4. Then 0.2. What is the total probability? What is the total? 1. Okay, so this is how you do the probability distribution of X. Okay, see what we have done? This is how you distribute the probability. Okay, and this is the probability of X. So when we talk about probability distribution, is how the random variables, the probability of the random variables are distributed based on how they occur. Okay, so let's see this is sampling distribution. I have explained sampling to you. So when we talk about sample statistic, you see there is no S here. We say sample statistic. We talk about the mean, the median, the proportion, and the standard deviation. And all these are represented by English letter. Okay, proportion. Here, X. They are all represented by English letters. Unlike the population, whereby we have the Greek letters. Okay, so they are different. So sampling proportion or in sample statistics or sample distribution. These estimates are represented with English words, letters. Okay, so 6 now, sampling distribution of mean. Take note of this. We stop here today. Okay, then you go spend the remaining time for your assignment. Next week, we'll continue. Let's go check the attendance. So those of you that have not scanned, please do that.
Check